congruent to angle A. And that's going to be your corresponding parts of congruent triangles are congruent. So typically you prove the triangles are congruent, and then that leads to a CP, CTC step. So if you're ever proving angles or sides are congruent, that's like your last step. So you're like 50% done.
Mhm.
Okay. So but this is where the real challenge begins. The real challenge begins because like, well, what do I do next? And the answer is you have to look at the the drawing here. You need to not assume, but like what can you say for sure is congruent, but have a reason for it. And so there's nothing really to start here. Like they're not telling you that something's an angle bisector or that it's a midpoint or anything like that. So if you don't have any definitions of like or a midpoint or an angle bisector or anything like that, you next look to see if anything is shared. Is anything shared in the triangles?
Is anything paired?
Shared,
Oh,
shared. Like you have a
ECA maybe that side or
which side?
wait, by shared, would it have to go on to both sides? Like,
Yeah, it's like if you and your sister have a wall, you
yeah,
share a
maybe
wall.
maybe ECA.
It has to be sides and angles are shared, but ECA is not a side. ECA is like two sides.
Mhm. Oh, R and C.
Yeah, so RC segment is congruent to CR.
Wait, what's that called? I remember learning that in class. There's like a, is that
It's
a,
reflexive,
yeah, reflexive.
reflexive. So it's like you look at yourself in the mirror, same guy is standing there.
Mm-hmm.
That's reflexive. So you can then do this. And what you're always doing is you're always looking ahead. You're like, what do I need to prove the triangles are congruent? Three sides, two sides in an angle, two angles in a side, two angles in a side, but in a different order. And now you have it. Are these triangles congruent? Is the top triangle congruent to the bottom triangle?
Yes.
Yeah, now the order matters here. So it's triangle something, 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 the three letters is congruent to the other one. So you gotta pick like a starting point. Like let's just say you started at E. You're starting between the single and the double. You can go in either direction. Let's say you want to go to R. You're going down the single side back to C. So let's say
Back
you
to
just chose ERC. Well, what's the correct starting point for the bottom one? Well, you got to start between the single and the double.
so ARC.
Yes. And then you have to say that side, 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 because that's what you're using.
And then the fifth one we already have.
Fifth one is, and then now that the triangles are congruent, you can say any piece of it is congruent. Thoughts on that?
Yeah, that makes sense. Doing good on that.
Okay. So for number two, see if you can set up the first couple of steps. I'm just going to step away for 30 seconds, but I'll be right back here. But see if you can set up like the first couple of steps, the givens, and then we'll talk about what to do.
Okay.
Okay, I am back. Again, it's an S and an R situation here.
Mhm.
And it says that I is the midpoint
Midpoint of CM
of CM, that's given. And then two, I is the midpoint.
for BL.
Yeah. Now you can actually you can actually combine those into one given, depends on the instructor. But this is different than the previous one because it's not like it's saying that the sides are congruent or the angles are congruent. It just says it's the midpoint. So what does
Yeah,
it mean if something is the midpoint?
means where that like things come and meet together where they hit, or maybe where they're not equal to, but like um where they come together in the middle.
Okay, so let's say you get a Subway sandwich 2 foot long and you cut it down the middle.
Yeah,
What do you know about each side?
each side is 6 inches.
They should be the same.
Yeah, they should be the
They're
same.
congruent. So the midpoint tells you that C to I is congruent to M
C
to
to
I.
right. Okay.
So that's your next statement is that C to I is congruent to M to I. Now the reason's a little bit more challenging to figure out. I'm going to give you the reason here. It's the definition of a midpoint. So it's not enough to just say, well, because it is. You have to say that, well, since it is a midpoint, the definition of midpoint says that the two sides are congruent. And
Definition of midpoint.
this is where most students struggle because they don't know what to write. They don't know what to write because they don't know why they have to say this. But that's what's the requirement of a proof. Proof is I tell you something is true, you say the definition of the true thing, and that's what the result. So what does it mean if I is the midpoint of BL? What does that mean?
That um I is between that we can make a line on both sides for them because
L to I is congruent to B to I.
you know,
Right? Same idea. You get a burrito from Chipotle and you cut it in half, and each side is the same. So you would say Li is congruent to Bi. Now the question is why? Why are they congruent? Well, it's no different than the previous one. What's the reason the previous ones are congruent?
definition of midpoint.
Definition of midpoint, right? It's not that complicated when you just use the thing that it is, okay?
Mm-hmm.
Now our goal is to prove that segment CL is congruent to MB. You're going to be first proving that the triangles are congruent. I think it's always a good idea to list out the 4 possibilities, okay, and kind of see which direction you're going. Like right now, you have 2 sides congruent, so it's probably not ASA and probably not AAS because those require 2 angles.
Oh, I think it's side angle side
It is. Now we get to the important question, which is why. Why is it side angle side?
because we have well, is B and L considered that's not considered a side, right? When they meet together, that's
Nope, this is you need to prove that the angle between the sides is congruent.
the angle between.
So how do you prove that angle 1 is congruent to angle 2? Like why are they
CL
congruent?
CL is congruent to BM,
Well, that's a side now. What do you know to make those congruent?
but we have I guess,
Nope.
where they meet in the middle.
What about angle one and angle two? They're congruent, but why? What kind of angles meet at an X?
Maybe I'm just not. I don't know. What kind of?
We did many of these problems last week. What kind of, remember any of those words come to mind? These are called vertical angles.
So is it that one and two are
Angle one is congruent to angle two.
because of a vertical angle?
Definition of vertical angles.
See, I was not. I mean, that makes sense. I thought that we had to like write out something about either C and M or B and L and how that makes it equal, but I understand that.
All right, so now we've got that a side, an angle, and a side, an angle, and a side. Now you can say that the triangles are congruent, but the order matters here. And this, I don't know how much we worked on this last time, but like it's, you got to be really careful. You got to pick a starting point, and whatever path you go down, it has to be the same path um, as on the other side here. And I always think back to the Apollo, I think it was Apollo 15. NASA loses or the space ship, some catastrophic failure. The engineers, astronauts can only communicate by radio. There's no video. They have to explain stuff to each other without visuals. So, like when you explain your path, you have to explain it in such a way that the other path is the same. Like I keep trying to say, like, let's say you start at C and you go down to L. Well, that's the non-single and double side. You're going down C to L, then you're going down the double side and back, for example. But you could actually start anywhere. You could start any one of these vertices. So could
Okay,
you
so CL and then would it be I
I?
or
Yeah,
yeah?
yeah, you have to always go to the third one. So what's the corresponding one on the triangle on the right? Like what's the vertice that's corresponds to C?
BMI.
So B is off the two, C is off the single.
Oh, MBI.
There you go.
So that's the matchup.
Yes. And that's side angle side. So then that last step, and again, like if you don't know how to do the proof or you're really struggling, you should at least put in the last step, maybe get some credit.
TL to MB. Got it.
Okay. All right. Any questions on that before we proceed?
Nope. Try the next one.
All right. How can you set this one up?
Well, we see that SE is to SU. And then wait, what does that greater sign MES part mean?
Angle.
So that's our angle. Okay. So then
Yep.
angle MES to OUS. So
So how do you start the proof though? What's the first thing you put down in a proof?
You put the given part. So
That's
like
right. So you start
SE
with,
to SU.
you're good. And that's given. It's also good to label it in the drawing as you go. Angle MEF is congruent to angle OUS. So that's this top one is congruent to that top one. That is also given. So unlike the previous problem, they're not giving you a bunch of they're not giving you a bunch of definitions or not the things that could be used as definitions. They're just telling you they're congruent. So always go back to this list here, angle, side, angle, 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 side. So you've got a side and an angle in each triangle right now. So it's probably not side, side, side. It could be any of these three at this point. So at this point, I'm going to leave it to you to sort of tell me, do you see anything else that's congruent in the drawing?
Oh, wait, what about 1 and 2?
Yeah, what about them? What do you see there?
Well, side 1 and side 2 do look congruent.
They're not sides though. It's an
Or
angle.
like, oh, angle.
Okay, why are
Um,
they congruent?
because of E to 1 and maybe U to 2. We have wait, can you not like write out um shit, I don't know what I'm trying to say. Can
Well, they are congruent, but why are they congruent? What are the reasons that you know you can prove angles are congruent?
are these vertical?
Well, what makes them
It's an
vertical?
X.
Why were
X.
these vertical angles? Yeah, they meet at an
Yeah.
X. So do these angles meet at an X?
Yeah.
Yeah. So they are congruent. Angle one is congruent to angle two. Why? Now the why. What is the reason that we used in the previous proof?
The vertical.
More than that,
Um Definition of vertical.
there you go. Yeah, you gotta have that. I'm not like big on spelling everything out. Like some teachers are like theorem 13. Like,
Mhm.
I mean, just give me some words. If you said vertical angles, I'd probably be already all right. Oh, he's in the ballpark of reasonableness. All right. So now are the triangles congruent? And if so, which of these is it? Is it side, side, angle, 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 side? Keep in mind that the order matters. The angle has to be between those two sides. The sides has to be between the two angles. It has to be an angle, and then a side.
I don't think it would be angle side because isn't our side in the middle?
Yes.
So let's go angle side angle.
All right, very good. So now give me the triangles. What are the triangles that are congruent this time?
EMS
E
UOS.
triangle EMS congruent to triangle OUS.
Mm-hmm.
Is that the order letter?
Yeah, I agree with that.
Okay, so E is kind of starting up here at the angle that's congruent.
Hmm.
O is down here at like sort of off in space
Wait.
away
No,
from.
no, no. U UOS.
Okay, that's better. Okay, angle side angle. All right. Now, why can we prove that the triangles are congruent? I'm sorry. Now, why can we prove why are the sides congruent after the triangles are congruent?
The CPCTC part.
Yep. Yep. That is
Nice.
it.
So wait, on something like this,
Yeah.
well, on our last problem we had 7 steps, and I'm sort of confused. Like once we get to the CP, because that was we had to write so many definitions.
Well, they're all different. There's not a, it's not like algebra where I can give you a related problem. Like
Yeah.
they're all different.
Okay.
Once you prove the triangles are congruent, the next step is almost CP/CTC.
Hmm. Got it.
Any questions on that?
No.
Right. So before we do four, well, as we start to do four, I thought we're going to have this issue in the previous one. Often, often you have to separate the shapes, especially in a proof. You might be like, what is he talking about? Well, we're looking at triangle FRM, which I'll draw here. That's this one. Okay, that's FRM.
Okay.
And then AMR. AMR is this other one. It's often good to separate them. The other type of problem you'll have is where you have to add lines, which the more common one is that you have to separate them because of the overlap. Okay, and you'll see why in a moment here, but this is a pretty common technique that they should be talking about in the classroom. I think that they tend to just think you can see the overlapping shapes, but really if you separate them, it's a good thing.
Mhm.
So it's given that FM is congruent to AR and angle FMR is congruent to ARM. All right,
All right. So
so
we can write that out.
we can start our proof, yeah, with
Yeah.
all of that already.
Okay. So statement, reason. I have FM to AR.
So when they just give you an angle or a side, there's no definition.
Hmm.
There's no definition. Again, it's probably good to write down the four possibilities.
Yeah.
And, even though maybe it looks like a right triangle, you can't assume that, assumptions make a, blank out of you and me. Um, you just gotta be careful there. Just because it looks a certain way, you know, um, you gotta be careful. So, uh, we got an angle and a side. So it's probably not side, side, side. It's probably one of these three. And sometimes you do have to go back to the original drawing. But do you see anything else in the red and the blue that looks congruent?
Yes. Wait. Can the top and bottom pairs have a part in this? Like maybe
Pairs, or you mean sides or
like
angles? What do you mean?
FA and MR. Those.
Sure.
but
I mean
then they
that,
meet in the middle and there's no point there.
but they're not like you have to you're trying to prove one of the followings. Either FR is congruent to AM, okay, or maybe like angle F is congruent to angle A. Like that's what you're trying to prove. Like you have to get something that works here. That possible. Um,
Then is it possible that these are the only two?
no, no, no. I mean, I'm just saying like there's you're trying to prove side, angle, side, angle, side, angle. So let's just say we wanted to prove uh angle, angle, side. Angle, angle, side works if like R is congruent to M, because then you have an angle here at R, an angle here at M, and then a side.
So how do we write that?
Well, but is that true? Is R congruent to M? Like, is there anything in the drawing that's just that they're congruent?
When you have the triangles like that in the red and blue, like below the actual diagram, they look congruent. But then when they're crossing over, R and M don't look congruent because they're both on the bottom.
Okay, so let's go back and look. Yeah, let's go back and look at the first proof we did today. What did we use to prove these two triangles were congruent?
Side, side, side.
So how did we get the third side?
Oh, the ref reflexive
So but why? Why was it reflexive? What was it about that that was so important?
because you couldn't like we knew that they were congruent, but there wasn't a way to show
I used an important word here. Like the sides are. Why were these sides congruent? I guess what did we end up using?
reflexive,
Okay, so what reflexive means something else. Like it's what's another word that you can use for reflexive?
like in real life or in math terms.
What anything. Like I guess I just don't feel like you fully get like how how you're supposed to when you're looking at a picture like this one down here, how are you supposed to you can't just make up, well, I think the angles are congruent, I think the sides are congruent. There's only one other way to prove a side's congruent. And it's the same situation here as in the first one. What do you notice about the letters down at the bottom of both triangles?
It's M and R and M and R.
Okay, so
So we
they're
can
the same.
RM is congruent to
Yes,
um MR. It has to be different,
right,
right?
right. Now why? Why are they congruent? Why were they congruent in the first one?
Because of the reflexive.
Okay, and what makes them reflexive? Like, why are they reflexive? Okay, so they're shared. They're shared. That's the important word here. That's why they're reflexive. Both triangles share the same side. So if you're doing a proof on your own, you can't just say things are congruent. You have to say, oh, they're because they're shared or they overlap. That's, I mean, that is reflexive property, but you don't want to just make up, reflexive property. You want to know why it is. Okay. So now, are the triangles congruent? Do we have enough to show that they are congruent?
Yes, I think
Okay,
so.
I agree. I agree. So which one is it? Is it side, angle, or angle, angle, side?
Side angle side.
Okay, I agree. So now tell me
I have
which triangles, what's the letters that we're going to use?
FMR. Wait, no, I want to use F.
First one doesn't matter, but you can pick whatever order you want for the first one as long as it's the same.
Right, FRM.
Okay.
Wait, but no,
What?
that's gonna end weird for
No, it doesn't matter. I mean, it really doesn't matter. Like any of them work. You just have to be consistent.
FMRAMR.
Okay, so tell me about F. How would you describe F to someone that couldn't see it? What's it between?
It goes to R. But what do you mean by between? Like the 2 points? It's between M and R.
So let me make another drawing here. What is F between?
It's between a star and a number.
Yes, or whatever, something, right? So how would you describe F? What is it between?
A and M.
What about this line right here? Like no line and a single line.
M and R.
But you said the right thing down here. You said it's between a star and a number symbol. Like you didn't worry about the letters.
Oh, between
It's between a single
between a single line and
and a no congruence line.
yeah.
So which letter over here is between a single and a no congruence line?
FMRARM.
That's much better. All right. Now, we didn't usually you have to do all that, but this time they actually tell you which one to use. But you can you can you can you know you can use your own letters too. So that's step 4. And the reason is side, angle, side. And then if you wanted to, you could prove any other sides are congruent or angles. But that is everything for this proof.
See.
So there's no set number of steps. There's no,
Yeah.
it depends on what it is. Okay, I really think we need to work on triangle congruence. So we are going to do that now, hopefully. Right. So all right. So this is enough information to prove that these two triangles are congruent.
Yeah.
So again, our four options are really important that you have
Side,
have
side,
those down.
side.
Yep.
Side, angle, side, angle, side, angle, 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 side.
And then occasionally hypotenuse leg, which actually applies to this one, but for the moment, presume that that one is not available to you.
Okay.
So which of these is it? And it's kind of based on what you already have. What do you already have that's congruent? You got the red box, which is an angle,
Yeah.
and this other thing, which is a side. So,
So that's two angles.
well, no, each triangle is one angle congruent to one angle, one side congruent to one side. So it's probably one of these three. Is there another angle congruent?
Well, I see two angles,
Okay. Yeah, these angles are congruent. Is
but
there
that's
another angle that you can go at?
yes. X and B.
Okay, so how do you know?
Re- um, reflexive, but is this?
Angles are never reflexive unless they're shared.
Oh, I thought this was good.
How about sides? Are there any sides that are congruent?
XWKV.
How do you know? Is it because they look the same, or is it because there's actually a reason for that?
Well, I said that because I think they look the same, but there
Yeah,
probably is a reason. Is
you
it?
cannot say it, yeah, like I don't. I mean,
No, I know, but I just yeah.
look the same equal fail the proof. I mean, you cannot do that. Like that's really really bad. Um, one of the techniques we talked about is separating the two triangles. So this angle is congruent to this angle, this side's congruent to this side. There is another side that's congruent.
Wait, can we make the two marks on that side?
Oh, give me the letters that you're referring to.
X XWKV.
No, no, they are not congruent yet.
XK. We already have that.
Okay, so what do you notice about this side right here?
XV.
What
It's
do you notice about that side in both of those triangles?
there's a right angle on both of.
It's shared.
Wait, but I thought that we just did a shared and that was a reflexive.
It is, but you have to somehow. I don't see that you're getting you're seeing that. I mean, if it's shared, they're congruent. I think the house analogy is the best one. Okay. You have a bedroom, your sister has a bedroom. Like if the wall is shared, like you don't need to like look at it from both sides to know it's the same. It's the same freaking wall. Like it's right there in the middle. Okay. So if it's shared, they're congruent. I mean, or use an example of a you know outside your house. You got a wall outside your house. It's the same wall whether you're looking at it from the front or the back, inside or outside. So these sides are congruent.
Due to shared.
Well, it is called overlap. It is called reflexive, but I'm looking for a better word than that. Like I'm looking for you to understand that that means that it's really shared.
Okay, I understand that. So I can't say
You
that's
can't
not reflect.
The reason is the pure definition is reflexive, but that's kind of like it's a $5 word. Okay. It's like if I tell you, if we're in a different class, we talk about like gerrymandering or something, and like, what is that? It's like, no, just give me the basic definition. Like, what does it mean? It means they're shared, right? Like you and your sister have a dog. I don't know if that's true, but let's just say you did. Like it's shared. It's not yours. It's not hers. It's shared, or it's a family dog, right?
Mhm.
That's the idea here.
I understand the shared concept, but I feel like so when I say reflexive, that doesn't. I have to say shared. I have to write down shared.
No, I want you to know that it's shared. Reflexive is the right word.
Oh, okay.
The why it's reflexive is because it's shared. All right. Uh, that's okay. I mean,